Hello everyone, I'm Damon from the Dever team at Nodit. I really wish I could be there in person for today's meetup, but it's a shame I couldn't join you on site. But I'm here online to walk you through what Nodit is and how you can use it to build AI-powered applications using real on-chain data. In particular, I will highlight something we call the Nodit blockchain MCP, a new way to connect LLMs directly to the blockchain APIs. So this session is also meant to help you get ready for the ongoing hackathon. We are currently wrapping up the wave two, but it's not too late. You are more than welcome to join from wave three. Throughout this session, I will share Node features, examples, and hands-on tips to help turn your ideas into real submissions. All right. So let's get started with a simple question. What is Nodit? Nodit is a full stack Web3 developer platform. That means we provide both the infrastructure, like blockchain nodes and data level APIs to help you build faster. Let's say you're building a DM. You will need a way to interact with the blockchain. You could run your own nodes, but that's expensive and hard to scale. Instead, with Nodit, you can access our managed node pools shown here in the middle of the slide. Just use our Node API to connect them, and you are ready to go. If your application needs real-time updates, like reacting to on-chain events or monitoring wallets, you can use our webhook or stream services. But Node goes beyond node access. We also index blockchain data and provide it through easy-to-use APIs. This lets you fetch data like tokens, transactions, or NFTs without digging through raw data or writing your own parsers like that. So now that we've seen a big picture, let's take a look closer at each feature. Um, the first, Node API. This gives you um, direct access to blockchain networks using standard node client APIs. For example, for event chains, that means JSON RPC methods like if core, if get logs, or if get balance sort of things. You can use these just like you would with your own node, but without having to manage any of the infrastructure. By default, you will be using our Elastic nodes. These are part of our shared node pool and are ideal for most hackathon projects. For production or high throughput use cases, we also offer dedicated nodes, and those are part of our paid plan. Let's take a look at how you can actually test and explore these features yourself. What you're seeing here is our developer docs, and every API comes with a built-in playground. So click API references on the top, and on the left, you can browse by chain. Um, for now, I'm going to choose Ethereum, and under that, you will see the category like Node API, Web3 API, sort of things. Let's expand the Node API, you will find a familiar um, methods like this. I'm going to pick a it get logs, and you can find the base URL, and you have to enter the API keys, and also you have to select the network you want to choose. I'm going to select Ethereum mainnet, and you can use any value that you want to search. I'm going to keep it with a default value for the parameters, and you can get a response from the developer docs right like that. And also it will give you the example codes like this. So if you want to get um, if you want to use in your project, you can just copy this example codes and paste it into your file directly. And so next, let's talk about the how Node helps you react to the blockchain events in real time. First, a webhook. With webhook, you can receive push notification to your server the moment on an on-chain event occurs, like a token transfer, transactions, or smart contract interaction. All you need to do is register your endpoints and define your filters. It's a perfect fit for event-driven applications like triggering backend logic when a wallet receives funds or when a specific contract is called. And the best part, no polling needed. Um, Node delivers the data to you instantly. And next stream, if you want to monitor blockchain activity continuously rather than just reacting, um, then Stream is the better option. It supports the same event type as Webhook, but instead of setting HTTP callbacks, it opens a persistent stream connection. So while Webhook pushes data to your server, Stream lets you put it in real time over on open channel, like on WebSocket. This makes Stream ideal for dashboard, analytics, and anything that needs a live feed of a blockchain events without delay. Let me show you how easy it is to set up a webhook in Nodit. First, from the Nodit console, you go to webhook section, and there's no list because I haven't created any webhook. So let's create a new one. Click the create webhook button here. And here's the setup screen. You can choose the project and uh, the network. I'm gonna choose Ethereum mainnet and pick a event type. You will go for a block period, which triggers the webhook on every new block. Next, we have to enter the webhook URL. This is where the data will be pushed. So instead of setting up a real server, and we are going to use webhook.site for testing. A simple tool that gives you a temporarily public URL to receive webhook data. I'm going to copy the generated URL from webhook.site here and paste it into webhook URL field here. Now, depending on the event type you selected, you will see a set of you can test the webhook to with this button, and you have to set a of conditions that need to be configured. For example, since we choose block period, we need to specify how often the webhook should trigger. I'm going to set it as 1, which means the webhook will fire on every single new block. So once everything filled and created, that's it. Uh, every time a new block is produced on Ethereum mainnet, Node sends a payload to the registered wallet like that. So you can see the full data, including block number, hash, gas used, and more from this webhook. And this is really powerful way to build real-time blockchain applications without writing polling logics or managing background jobs. So now let's take a look at how to use the stream for real-time blockchain monitoring. In our developer documents, if you scroll all the way down to the left-hand menu, you will find a stream quick start page here. This guide walk you through the full setup from installing a Node.js and Socket.io client to writing and testing your code. But I've already set up the environment, so let's jump straight to the example code. I'm going to copy the sample and paste it into a local file. You can replace the fields that we have to like message ID and descriptions for the this stream, and you have to enter the API key from our. You can get this value from our Node console and set the blockchain network you want to connect. And let's run this local file. And here comes the first block like this. And this is how you can tap into a live blockchain data feed, ideal for dashboards, bots, or monitoring tools that need immediate response to chain activity. So far, we've been working with our raw on-chain data, whether that's via the Node API webhooks or streams. These are great for real-time access and full control, but sometimes what you really need is structured and developer friendly format data uh, without having to manually decode or parse logs. That's where the indexer API comes in. It gives you access to parsed and structured on-chain data exposed through GraphQL interface. With it, with Indexer API, you can easily query a specific field like all transactions from a particular address, immediate contract events, or current research states. And because it supports the fine-grained filters and selection, it's ideal for applications that need precise and targeted access to on-chain state. And think of it as your gateway to clean, searchable, and developer-friendly blockchain data. So let me show you how you can actually try the Indexer API through our developer docs. So at the top of the docs, just click on GraphQL tab. This brings you on interactive GraphQL Explorer like this. On the right-hand side, you will see a full list of available schemas. You can click any of these and select the fields you want, and the query will be generated automatically in the editor. And once you click the try button, the query runs and you get a live response right away. And if you want to narrow down the results, you can use the where clause and to apply filters. For example, filter by owner address like this. So just keep in mind that this Indexer API is currently available only for Aptos. So if you are building something on Aptos, this is a super useful tool to access rich on data without parsing it manually. So another feature that builds on top of index on-chain data is the Web3 data API. This provides a RESTful API to access structured data, including tokens, NFTs, accounts, and transactions. All of this is pre-processed and ready to use. For example, you can get uh, the token balances for given wallets, or look for token or token or NFT holders, or retrieve transaction details without having to decode raw data. It's perfect fit when your application needs the clean, reliable data, whether it's for backend logic, analytic dashboards, or front-end display. So let's see how it works. So first, from the top menu in the docs, click on API reference. Then on the left-hand side, choose a blockchain. So you will go with XRPL and open the XRPL Web3 Data API section. You can see all supported endpoints for this chain. Just quick note, the base URL of Web3 Data API is different from the Node API. I'm gonna use a sample transit hash and try. Also, you can use optional flags like with balance changes and with token transfers. But these flags are let you control how detailed the response is, and they differ by endpoints. And if you go to the console like this, and you can open the request logs page, then you can see a full history of our API codes like this. So this is super useful for debugging or performance monitoring when building with the API. All right, up to this point, we've looked at what Node is and how it works. Um, but why Node? Why would you use it over building something yourself or combining other tools? In the next few slides, I will show you how Node saves times and reduce complexity and let you totally focus on building your DApps only. Oh, let's say you want to get a list of ERC20 tokens held by a specific Ethereum account. The first challenge is you need to know the contract addresses of all tokens that the user might own. But here's the thing with JSON RPC, JSON RPC APIs alone, there's no way to get this um, list. So the chain doesn't give you a token summary per account. So even if you somehow collect those uh, contract addresses manually, you still have to loop through each one, calling the balance of function again and again. The more tokens you want to check, the API, the more API calls you have to make. It's slow, inefficient, and hard to scale. Now compare that to Nodit's Web3 Data API. With a single call, you can fetch all token balances for a given wallet, fully indexed and ready to use. That's because we pre-process and structure on-chain data, so you don't have to. Um, it's quite useful uh, to get to get uh, those kind of complex data. And now let's look at another example, the XRPL. Each blockchain has its own data model, and XRPL is a great case of how things can get complicated. Um, in XRPL, token transfers don't happen through a simple transfer call. Instead, they can involve concepts like rippling, pathfinding, and multi-hop payments and issuers. So you can see how simple transfer might go through multiple paths or middle steps. Um, the on the right side, the screenshot, I've captured the actual states changes from the single XLPL transaction on a block explorer. As you can see, it's overwhelming, especially for someone new to XRPL. There's no way, there's no easy way to know what actually happened unless you fully understand the protocol structure. And the XRPL has more than 50 um, different transaction types. And the problem is each type has a different set of fields and structure. So if you want to analyze on-chain activity, you have to handle every one of them separately. But we went deeper. Right? XRPL records state changes in ledger entry nodes, and among them, two are especially uh, important. Ripple states, which tracks tokens, token balances, and trust lines, and account root, which stores core account info like XRP balances. We studied how these entries changes across all transaction types, and we built a unified transaction model like this by combining just those two key sources. The result is what you see on the right, a clean and consistent structure with transaction details and balance changes and token transfers, no matter what the original transaction type was. So anyone can now read and use XLP transaction data without decoding over 50 transaction types. So as you can see, our focus so far has been this. How can we make on-chain data easier to access and work with? From indexing to API design, every part of Nodit is built to remove friction for developers. But what if we could take it even further? What if we didn't have to query anything at all, and your AI model could just understand the context and fetch blockchain data on its own? That's exactly what MCP is designed to do. In this next slides, I will introduce how Nodit MCP server connects LLMs to blockchain APIs and makes the entire process even more seamless. Let me briefly explain what MCP is, the Model Context Protocol. LLMs like Claude or ChatGPT are great at reasoning, but they cannot access real-time data or APIs on their own. They need a context to think, and they need tools to act. This is exactly what MCP is designed for, enabling models to retrieve data through tools like APIs. It gives LLMs a structured way to use tools like APIs. So instead of manually feeding data into a prompt, the model can call APIs itself exactly when it needs them. So the idea is very simple. Model thinks, tools act. This is uh, MCP is the protocol that connects the two components. So now that we have a basic understanding of what MCP is, so let me show you how it actually fits into the system with a bit more structure. So this diagram shows how an MCP host like Claude or Cursor connects to an MCP server. This server can fetch data from different context sources like local files, external APIs, or in our case, Nodit. When you use Nodit's MCP, the model doesn't just receive a passive input. It can actively query Nodit APIs in real time to fetch blockchain data respond intelligently, or even trigger logic. In this setup, Nodit is not just a backend. It becomes a tool the model can use directly. To make this even clearer, here's a side-by-side the comparison of what happens with and without MCP. On the left, without MCP, the process is manual. The user has to write code, call APIs, collect results, and then inject all of that back into the model's prompt. This takes time and it breaks the flow, and it doesn't scale well. On the right, with MCP, the model can call Nodit APIs directly through a structured protocol. So it decides when and how to fetch data and uses the data on its own in real time. So in short, without MCP, you are doing all the work for the model. And with MCP, the model becomes an active agent. So one that can ask, fetch, and reason dynamically. Now let me show you how what this difference looks like in an actual conversation with Claude. On the left, Claude is running without MCP. I ask it to analyze an XRP transaction, but because it doesn't have any built-in access to blockchain data, it resorts to um, searching the web, trying to find something on public explorers. But eventually, it just gives up. I wasn't able to verify the status, blah, blah, blah. And this could mean several things. So it's trying, but it's guessing because it's blind to real data. On the right, I use the Claude with Nodit MCP, which is connected to the Nodit APIs. This time, the model doesn't just respond; it actively investigated. So I ask the same thing, and then first it uses MCP to list all available API categories, then checks the XIPL specific APIs and loads the API specification for each. It understands which endpoint is relevant. In this case, get transactions by hash, and even constructs the API call with the right parameters based on the user's requests. In other words, it reads uh, the developer documents, so you don't have to read them. You just say what you want, and then and the model figures out which APIs uh, to use and how to call it and what data to extract. The result is clear and complete like this. You get a proper transaction details and data, and even a UI-friendly visualization as well. Now Claude becomes more than a chatbot. With MCP, it's a context-aware blockchain analyst that knows how to use real APIs to get real answers. So now that we've seen what Nodit MCP can do, so let's take a quick look at how simple it is to set up. Despite being such a powerful integration layer, configuring MCP is actually very straightforward. So let's start with Claude, the desktop application. The first, you go to the close settings and open the developer tab. You will see a section for MCP. Click the edit config button, and next add a Nodit MCP server to the configuration file. Um, it's just a short JSON block, and we use npx to run uh, the MCP server package and pass in your Nodit API key, which you can copy directly from the Nodit console. Uh, Once it's set up, you will see the Nodit server running. If it doesn't start right away, just restart the XueDAO app and it should connect automatically. Now let's walk through the same setup on Cursor AI. In Cursor, go to Settings, then navigate to the MCP tab. Click Add New Global MCP Server. In the mcp.json file, add the noded MCP server in the same way as we did for Claude. Again, just update the API key with your own and save the file. Once it's registered correctly, you will see the MCP noded MCP server appear in the MCP tab, along with all the available tools. So that's it. This means a model can now call real noded APIs across chains using plain language prompts. So, and from this point on, your models can read API docs and understand endpoints and call your data services out on their own. In case you want to explore more about the Noded MCP server, you can also find it officially listed on the platform like Smithery and Glama. We've covered a lot so far. And now finally it's time for the last part. Let's talk about how the hackathon works and what's up for grabs, and most importantly, how you can win. So here's how Wavegg works. Instead of just one big um, submission at the end, Wavegg is structured into multiple short waves over the 2 months. Each wave gives you a chance to build, submit, and improve. So you don't need to get it perfect right away. Build something small and iterate, or ambitious. Um, go ambitious from the start. It's totally up to you. And by the way, Wave 3 has just started. So even if you missed the earlier rounds, it's a great time to jump in and join from here. And when you are ready to submit, you will do it through the Akindo platform, where you will upload your GitHub repo, demo link, and quick milestone summary, including how you use Nodit. Your milestones are completely self-defined, meaning you get to decide what success looks like in each wave. And as you build, it's totally fine to change directions in the next wave, as long as there's a clear and reasonable rationale for the shift. Each wave is judged separately, but if you show consistent progress, that gets additional scores. Let's go over how your project will be judged and how to make a submission for each wave. First, the judging criteria. You will be evaluated on a mix of creativity, functionality, technical quality, UX, and documentation. But most important thing uh, um, is that we're gonna look at how well you use Notice features in your project. That includes our Node API, Web3 Data API, webhooks, streams, and especially the Node MCP, which lets AI agents interact with Node directly. If you use MCP to build something AI integrated, you will get bonus points. But even if you don't use Nodit MCP directly, we highly encourage uh, create combination of AI and Nodit in any form. Now about submissions, you will be submitting through Kindle, and we will ask for your GitHub repo and demo or video link and milestone summary for each waves. And most important thing is a clear explanation of how you use the Noti. And one important thing is to keep in mind is since we'll be reviewing a lot of submissions, the judges may not be able to go through every lines of code in detail. So if your README doesn't clearly explain where and how Node was used, the judges might not even see it, and your project could miss the short list. So even if it's amazing, so please make it specific. Point us to the files, functions, or configurations where Node was used. And one more thing I want to share is how winners will be selected in each wave. For every wave, we plan to select one or two standout projects, but this isn't strict limit. If we see more great submissions, we may recognize more winners. The prize amount is flexible as well, so it can vary depending on the quality, impact, and completeness of each project. Also, since this hackathon is web-based, we'll be watching how projects evolve over time. If you're if you participate from the early waves, you will have more opportunities to show progress, refine your ideas, and stand out. So when you submit, make sure to highlight what's new or improve since the last wave. And you are not just looking for, we are not just looking for a great code. We are also looking for the thoughtful iteration. So if you like to explore further or try out anything we showed today, here are some useful links to get you started. These QR codes will take you to the Node console where you can generate your API key so that you can use our features and the developer documents with all the technical details and examples. And for the last, the Node MCP server quick start page for connecting with your AI tools. And if you have any questions, feel free to reach out in the Noti channel on the Akindo Discord or leave a message, leave your question in the Q&A section of our developer docs. And okay, that's it from me today. Thanks so much for your time and attention. And I'm really excited to see what you're gonna build with Nodit in this hackathon. So good luck in hackathon and have fun. Thank you. Bye bye.